I want your feedback. What is the best design features in your current crash bars that you think are important that we should build into ours? How's it going, Lone Riders? It's Andrew here, and we make videos about how to develop products for motorcycles and motorcycle accessories. This week we're going to talk about how we are developing a few new products for the 1300 GS, and if you like that kind of stuff, do subscribe, leave us a comment if you see something in the video that is interesting or we should do. The reason why I'm making this video is because I just want feedback from you guys, because what we do is we have a loop. So we make the video, we make the design, we get feedback, and then we design that back into the product. So, so we're designing it together, developing it together, because we know our market, we're good at developing, but there's thousands of people out there with different riding styles. They ride in different environments, they want different things, and so we're tapping into that and doing the best we can to give everybody a really good solution to their needs. So that's what we do here, and so let's just jump into the computer and take a look where we are at. Just recently the 1300 came out, and we got some spy shots, but we never actually got the bike. The bike is actually in dealers and people are riding it. You can see online it's just exploding. So we've been designing for this bike for a few months now, and just with the images we have, the spy shots, I've made a few videos on that. So what we've been doing is trying to figure out the ways we can put our products on this bike, just with the images. So we're not lucky enough to have the actual bike like some other companies to scan it like several months ago. So what we've been doing is developing the products on just the images. So one of the first products is the luggage, because we make a lot of soft luggage here. Semi-rigid bags as well. Semi-rigid is kind of the beautiful mix between a hard pannier and a soft pannier. So hard panniers, this is a completely different video, but essentially hard panniers are more secure, but they also can break your leg pretty quickly. And when you're really tired and you got like a ton of mud on your boot and you try and lift that boot and you drive forward, you can really snap your leg pretty quick. So the idea was to develop a bag that kept the rigid property of the metal panniers and the security of them, and then integrate that with the soft panniers, which are great because you can drop the bike on your leg or something or body part and it won't break. And it's also a bit more forgiving on the subframe on the bike as well, but less secure. So that's what the MotoBags do. That's the concept, and a lot of people have responded well to them. So if you look down here, was one of the first product videos, the good old watermelon trick, dropping a hard pannier on a watermelon just crushes it, but the MotoBags, semi-rigid MotoBags, it survived. So this is one of the products we're putting on, and we got the first images from BMW here, and they are offering one of their systems, which is a new upgraded Vario system. So we are going to develop a connection system between our MotoBags and this bike. We've got two different systems already. The MotoBags, we got quick release, which is the top one here, and that goes on to racks, and that's more orientated for off-road, because the racks offer so much more support across the bike, and it distributes weight across the bike. So when you do have a fall or crash off-road, that weight is distributed across more points than the below one, which has a 3-point connection system, and it hooks straight on. So the bottom one is called basically a rackless system. So it doesn't need racks, so you get a nice clean finish on the bike. You just pull them off, and the bike is basically naked. It looks really good. I have that on my GS Adventure, so I removed the racks because I think it looks cooler. And plus, I'm in a good position, so I crash my bike often. I can just replace my MotoBags, and that's great because then when I do crash them, destroy my MotoBags, I know what breaks, and I just reinforce that and make a better product. So that's where I am, and these are the two different kind of scenarios we're at. So we will be making the racks, as you see in the top right hand corner, because this development time is quick, and the development time for the rackless system that we've developed is a little bit longer, but we'll bring that into another video. So how do we design a product without the bike? What we do is we look at the stats that they brought out and the photos, and we model images on that, and we change the perspective of those images. It's basically, if you want to take something without perspective, you just go far away from it and you zoom in and take a photo of it. So that distortion is gone. So we use that method with some basic techniques, and the concept is just to get as close as possible. So the first step would be to make a parametric model. So a parametric model basically means we're making a model that is a rough estimate of what we will have at the end of the design phase, but everything can be changed. We can update it just with a few clicks on a table, and we can change parameters, and so we can quickly update that for when we do get the 3D program. So all these points here, all these planes here, these are all relatively accurate, but not quite. So when we're dealing with racks and metal and screws and stuff, we're talking about 0.02 millimeters of tolerance here. It's not much at all. We can change it so we can make it a bit more tolerant. We can make slots. You can see here's a hole and here's a slot. We can get away with a little bit, but generally we don't want to do that because it makes a sloppy product and it moves. And so this is the first stage. So we take the photo and we design around that photo with CAD. The second stage is we do a quick overall 3D scan. So we're quite lucky. We got contact with some suppliers or some dealers, and as soon as they got the bike, they said, yeah, come in and scan it. We have pretty good relationships with some of the dealers, so that's what we did. We did a quick scan, and the thing is, to do a quick scan, you need to spray the bike. There's scanning, it's improved a lot over the last couple of years. Like when I started 3D scanning the bike, just a small device, a handheld device, was about 15,000 euros. And it was very inaccurate. So we invested a lot in this already, technology. But these days you can buy just for this scenario, quite a reasonably accurate 3D scanner. The Pro ones go up to 100 Ks, and we do utilize this as well. And that gives a super accurate model of the final product. So that means we can actually build the design straight off that, and we're good to go. So the next step is basically 3D scan as much as we can, but because these are brand new bikes in the dealership, we can't just spray them, because often you need to spray these bikes to get a good surface finish on your 3D scan. So at the moment, what we're trying to do is just aim for the main bodies and the fixation points. So as soon as we've 3D scanned that, we chuck it into our software, and then we change the parametric model to be accurate. If you notice here, you can see that we've really honed in on those screws, those 3D screws that we've scanned, and we've built the model around it. So the turquoise image here is the scan of the bike, and the silver pipes, that's the 3D model that we've made from pipe bending, and that's the parametric model. So that's the design that we're going to do for the racks, and then with that we can put our quick release MotoBags on top of. So we're making our custom racks. So this is phase one. Phase one is just to make the racks as is, the standard pipe racks, and we're looking into the future would be phase two, where we make a custom rack where the attachment system on the back of the MotoBag marries up nicely and perfectly with the rack system as well. So the next step is to prototype these out. So this is the 3D rendering on the right hand side here, but what we're going to do is hand prototype these out and get them accurate as possible. So we can go straight into tooling. One of the easiest ways to do it would be to 3D print all the corners, so all the bends, so all these bends here, and then use pipes for the rest of them. And we have a good 3D printers, can get quite accurate, and we can 3D print this all out, connect it together, glue it all together, and then test it. That's one option. The other option is to go straight into metal bending, because we have such good accurate 3D models. Then we have to invest in tooling, and that tooling is the tooling jigs, so they stay in place when you weld it. The right bend angles are there. That's quite intense as well. So that's what we do next. We just basically prototype them up and we fit them to the bike, because at the end of the day, if it doesn't fit to the bike, yeah, it's not gonna work at all. So let's look at the upper crash bars as well. So we're doing the rear rack plate, what you've seen with the MotoBags, but we're doing crash bars. And this is where I want you guys to give me feedback on, because we've all been there, we've all dropped our bike or crashed, and hopefully everyone's fine, but we've all been there. So everyone's got their own experiences. So I'm pretty, I understand the concepts, and I'm looking really mostly at the physics side of it. So what happens on impact, and what are we trying to achieve, and what are we trying to protect? And that means I have to marry that up with the other side of the whole project, which does it look cool? Does it work? Is it manufacturable? Is it cheap enough to make where people can buy it? Because we can go all out and make a crazy design, but if it's too expensive to manufacture, no one's going to buy it. So we've got to balance all these things, and this is where I want your feedback. What is the best design? features in your current crash bars that you think are important that we should build into ours. As you see here, this is the first couple of renders that we're doing. The green is the 3D scan, and the other two bars here are the lower crash bar and the upper crash bar. The upper crash bar is a bit niggly. It's kind of all this front of the GS now is all plastic, and we need to get in there and start taking it apart. We're getting a bike soon. We bought one so we can take it apart and see what's really happening under there. But essentially, it's quite niggly up the top there. It's not really fitting. It's a bit soft. So we'll find a place, and I think we've found a place that was pretty solid, and we need to actually get our hands on the bike to finish this. But we're going to focus on the lower crash bars. So there's also fall planes that we integrate into where it falls, how it falls, and what it falls on. And we can see down here that our scan data is not perfect. We've actually updated that today, so we have good scan data. But essentially, this is our first round concepts of the crash bars. So if you notice here, this should be serviceable. So the cost of it for your service will be cheaper, so they don't need to remove all this. That's one good thing here. And we're really nailing it. This is not finished, by the way. Like, we're still going to put a plate across here to reinforce it, and a plate as a skid plate to stop stones getting up in there. That's what happened to me. Stone got up into my cylinder and scratched it. Didn't crack it, but scratched it. So it's there. We understand the point there. One of the really important things that gets lost, I think, is flexibility. So when you have an impact, that energy has to disperse somewhere. Like, it just doesn't disappear. So if you look at this, is the new BMW 1300. This is the OEM one here. This crash bar here is from BMW. But if you notice on the actual new models, I've got a reinforcement plate that goes across these two bars. I don't know if it's a reinforcement plate. There's a bit of styling probably in that, because this is a pretty solid system they've got here, but this is theirs. And I think it's really good. I really like it, because what it does is it sits on the engine there, and the places where it hits and needs protection, it flexes. So it's absorbing that energy. It absorbs that energy in and stops that energy transferring into the subframe of the frame of the bike and, bending out the bike. So then you're driving not straight, and you have other problems inside the bike, like things moving inside the bike and things like that. So the base design that they've done is really good. The thing is, I've also got a design for what people perceive as they need. So a lot of people really enjoy buying these bars that sit on the backside here and cross back in, so it's a 4-point connection. I put this on my bike as well, and I drove around Africa without it, and I didn't have a problem. And we crashed a lot because of the flex. It was fine. But that is a security bar. I also can call it an emotional security bar, and it does have its function. It does work. It's sort of solid, just stops it. There's no flex in it. It removes the flex of the bar, and it also works. But there's two chains of thought here. The flex people and the fixed solid people. I'm of the flex person, but I understand that the market demands that security. You're investing a lot of money into this bike. You want that security. So there's a compromise here. It's actually not a compromise. Actually, it's an improvement over the whole system. We're building in a kind of a rubber spring system where what happens when you actually do smash the bike on the ground with a great force, we're going to absorb that energy through the system, through the bars, and also through the rubber, a rubber system. This is one concept that we've done. So essentially it's basically, if you look at the impact will come from left to right and impact into this area here. That rubber should absorb most of that impact. It will absorb that impact and not transfer it across into the bike. So we could put a spring in here. We could do all this stuff. We could make it high tech and compression and all this stuff. But what we'll find is that people will destroy it and they want to replace it, and then we have to send it out, like just replace it, which we will, no problem. But we want to keep it low tech as possible. And often rubber is a good way of doing it because we can actually adjust the shores. So if someone wants more, we can reduce the shore. Shore is just basically if you press with your fingernail into your shoe sole, that's about shore 65. The harder the shore, the higher the number, the harder it is. So shore 90 is like a hard hat, and a rubber band's about shore 20, for example. So that's what we're doing here. So that's what we're doing here with this crash bar here. So it's in development. We're almost ready to produce some prototypes. It goes quick. We're just going to look at the top part here, look at the top crash bars, integrate it all through. But this is the chance where I can get feedback from you. So if you have feedback, what you think we should put in, should it be steel, mild steel, what kind of steel, if you know which steel we should use, or should it be stainless steel? What finish? Do you want black? Do you want white? What color? Anything. What's the thickness of the steel? What's the wall thickness of the steel? What's the tubular thickness of the steel? Bombard us with that information that you have in your head. I'd love to hear from you about it, because it's really interesting. And it's actually the final design is actually quite similar to the 1500. So they haven't changed some of the core dimensions. Of course, it's different. They've got a different frame. Everything's different. But some of the core physics of that bike, or create the physics of the bike, are all the same. At the front, except for the headlight up there, I'm also doing that. We popularized this headlight guard with the orange lens, just for visibility and safety. It also looks awesome. So we're trying to apply that concept to this bike as well. And it's coming up with mixed results, but I'll make another video on that. But this is the model that we've got so far. This is a very rough model. We've also updated that today. And what's cool, we can make a scan and then lay that scan on top of this and like build out slowly an accurate scan. So at the end of the day, we're going to have a complete model of every surface. It takes a lot of time, a lot of effort, takes several days, a lot of machinery. It's quite an expensive process as well. So, but we're getting there. That's the update. So far, we are absolutely mad around here producing products, coming to market as quickly as possible because you guys need that stuff. And yeah, introducing some really cool, innovative points as well into those products. So yeah, subscribe if you like this kind of stuff, and also sign up for the newsletter. It's in the first link in the description down below. And I'll catch you very, very shortly.